Greetings everybody. So today we are going to discuss about the lead accumulator battery. It is an example of a galvanic battery. It is an example of a galvanic cell application of galvanic voltaic cell. So here it is basically first it is important to discuss what is a cell and a battery. Cell basically it is a single unit. It is a single unit which is a stock of chemical energy. It is a single unit of cell. It is a single unit which is a stock of chemical energy, and it is a stock of chemicals in general. But when it comes to a battery basically is a group. It is a group of two or more than two cells which are connected with each other in order to produce electrical energy, and that electrical energy source provided is in the form of DC current, direct current. And here the battery we are going to study is lead accumulator battery, lead storage battery, or lead acid battery. Now here this battery is composed in such a manner that it consists of six cells. Usually it is consisted of six cells, but sometimes three cells are also present. Each cell produces 2 volts. Each cell produces 2 volts, such that if there are six cells, then it would be a 12-volt battery usually, which is the case. Otherwise, if it is a 3-cell battery, then it would be having 6 volts. This is the case. And now coming to the point, here we are having some its mechanism, that electrochemically what is the actual mechanism going on in the battery, such that each cell is divided from each other. Each cell contains two uh, electrode. One is the cathode, second is the anode, and within the battery there is an electrolytic solution which is dilute H2SO4, such that 30% of the electrolytic solution is H2SO4 and 70% of it is water or H2O, and its density present over here is 1.25 gram per centimeter cube, 1.25 gram per centimeter cube, and its specific gravity is also 1.25. One more thing here, we are also having its concentration, the molarly. What is its concentration? Its concentration is 3.2 mole per decimeter cube. 3.2 mole per decimeter cube. These are some important factors. And here it is dilute solution, and here we are having now its electrode, such that the anode utilized in this process, anode which is utilized in this process is lead or plumbum. Anode is lead or plumbum, whereas on the other hand side, if we talk about the cathode, cathode is lead oxide. Cathode is lead oxide. Cathode is lead oxide, as I would like to show in the diagram as well, that here oxidation occurs at the anode is lead, and cathode is basically anode is lead, and cathode is basically lead oxide. So this is what here it is about. So as you can see, oxidation occurs at lead, and reduction occurs at lead oxide. So it's in the diagram, you can also easily identify it. Now there is a point that here lead basically it is having characteristic that it has, according to the electrochemical series, we have a lead which is having less potential, which is having um, lead basically it is having less reduction potential or negative reduction potential as compared to lead oxide, as a result of which lead would be here considered as an anode, and hence it would be having a positive charge because of performing oxidation over here, while cathode would be considered as lead oxide because here it is having higher reduction potential, due to which reduction will occur, and thus it will tend to have a positive, have a negative charge. How, we are going to also clarify in the mechanism as well. Now these are things, and now in between all of these glass, in between all of these cells, we are having several fiberglass sheets. What is the mechanism? Fiberglass sheets are present here, so that these fiberglass sheets um, can prevent shorting during the physical contact to the battery, as well as there is also terminals are connected in such a manner that these batteries positive terminal are connected in series to one positive terminal and negative terminal are connected in series to the negative terminal. So this is the mechanism. Now without discussing more of theoretical things, we are going to discuss on the practical mechanism how it occurs. So the reaction first and foremost which occurs at anode the reaction which is occurring at anode the reaction which is occurring is such that at anode we are having lead, and lead basically loses its electron. Lead loses its electron, as a result of which it causes to give us a lead ion. A lead ion oops sorry Lead loses its electron, due to which it gives us lead ion. Now here these two electrons which are lost are now sent towards the cathode, as a result of which oxidation occurs at the lead and reduction occurs at the cathode, due to which these two electrons will be now sent towards the cathode. Electrons now sent towards the cathode, whereas on the other hand side lead which is now in the form of ion, lead which is now in the form of ion, where is it? Lead which is now in the form of ion will now react with sulfate ion dissociated within the solution. Sulfate ion dissociated within the solution, such that the sulfate ion and lead when react together will form lead sulfate. Lead sulfate. Now as lead sulfate is formed over here, lead sulfate is formed over here. On the other hand side this would be the reaction on the anode side, but when it comes to it is an oxidation reaction. You might be wondering how it is an oxidation reaction. Here lead is having plus 2, it is having 0 over here, and it is now converted into plus 2, so it is oxidation occurring. Now when it comes to cathode having a part that here cathode basically has the following reaction occurring, such that here cathode has a lead oxide. Now when lead oxide gets two electrons, as well as when lead oxide gets two electrons, it then causes to as well as there are sulfate ions present as well. So let us mention sulfate ions on the cathode side. So here as we are getting this electrons as well as the sulfate ions and lead oxide, what reaction which the reaction which will actually occur here will be again a reduction reaction, such that here lead here will be reduced, such that lead here is having its oxidation number as, let's find its oxidation number, it's minus 2 for uh, oxygen, so it is 2 to the 4, and here we are having 4 as its oxidation number. But when we are going to find the oxidation number after the reaction, lead will now form lead sulfate. Now as you can see, lead sulfate will have its oxidation number, let us just check that as well. Here it is minus 2 to 4 the 8 plus 2 for lead sulfate and plus 6. So here the oxidation number of lead sulfate is plus 2, which means here the oxidation number is decreased and reduction is occurring. As a result of this reduction occurring, uh, this would be considered as the reduction process, and on the other hand side the product which has been obtained, byproduct obtained, is oxygen. Now as you can see, on the product side we are having oxygen, and on reactant side we have oxygen, and product side is empty, which means two oxygen atoms are lacking. And we have studied that according to the ion electrode method, in an acidic medium, if two oxygen atoms are lacking, we are supposed to add uh, one water molecule for one oxygen atom. So for two oxygen molecules, we are going to add two uh, water molecules for two oxygen atoms. So this would be the case over here. But since we have added two water molecules, we need to add two what do we call it, protons as well, because protons are 4 on the product side, so we should have 4 protons on the reactant side as well. So this would be the final reaction after balancing it. So this would be the final reaction. Now these are the two reactions occurring at the anode as well as at the cathode. So this is the reaction which is happening over here. When it comes to some other part, when now the next step is studied in the ion electron method is in such a manner that the ion electron method over here says that once both equations, oxidation half reaction and reduction half reactions, are balanced, we need to add both of the equations such that now when are going to add both of the equations, when we are going to add both of the equations, we'll get our answer such a manner. By the way, here as there are four protons here, sulfate here, so instead of writing them separately, they will tend to react with each other and form sulfuric acid. Sulfuric acid. It will form sulfuric acid, right? So this would be the equation. Now, when we are going to combine both of them, those two electrons. We are writing two electrons because here these electrons are being released during the anode reaction. Now, when we are going to combine both of them, the overall cell reaction will be written as lead oxide. As we are having lead oxide, that will not be cancelled out because there is no such species present in the equation, and lead oxide over here, and on the other side we are having lead oxide, as well as when it comes to uh, the other part, we are having sulfuric acid, right? Sulfuric acid, and then electrons will be cancelled out from each other. The thing which would be left behind would be lead will be there, lead will be there, as well as when it comes to sulfate will be there, sulfate, as a result of which the product which would be obtained will be two lead sulfate and 2H2O. This would be the final equation obtained. Now let us just recheck if there is any sort of error in it, so that if there is an error we can just rectify it. So here, as we can see, there are one lead is there, one lead on that side, one sulfur, four oxygen. Yes, it is balanced. Now lead over here, one lead, one oxygen. Wait a minute, we are having four oxygen over here, two oxygen over here, six oxygen, four oxygen, two oxygen, six oxygen. So two proton, wait a minute, two to the four proton, two to the four proton are there. So there will be two sulfuric acid molecules, as well as there will also be two sulfuric acid molecules. So this is the overall equation which is finalized over here, and this is how calculate the reaction. Now after the reaction, when lead sulfate will be formed on both sides, cathode as well as anode, as a result of which the reaction will be completely finished, will be completely over when the electrolytic solution will be completely decomposed, which means both of the electrodes will be completely covered, 100% covered with lead sulfate. Then the reaction will be completely finished, and at that point the cell potential given would be 0.00 volt. So apart from that, this was a process which was considered as discharging of the sulfuric accumulator battery, lead accumulator battery. Now, uh, lead accumulator battery. This is the first process discharging of the lead accumulator battery occurring. And now, how can we measure that, the battery is being discharged? So there are a number of practical things we can do, which is accumulation of, lead sulfate, as well as we can check the voltage drop, as the voltage drop is being done, which means the battery is being discharged, as well as if there's accumulation of lead sulfate is indicating the battery is being discharged, as well as you know if there is if the voltmeter is showing less amount of volt, which means voltage drop is there, then we can acknowledge it, as well as if the battery is being discharged, it indicates that the reaction is occurring spontaneously. But after the battery is discharged, the battery is of no use. So in order to recharge it, it is a characteristic that it can be recharged as well, such that when we are going to recharge it, we are going to utilize an external electricity source, electrical energy source, which gives the power supply to the to the positive anode and negative cathode, such that cathode is connected with the positive terminal and anode is connected with the negative terminal. When both of these are connected, the reverse reaction takes place, such that at cathode there is oxidation and at anode there is reduction. Now reaction would be all same, only the difference which would come here would be in the reverse reaction. Here, instead of formation of lead sulfate, there will be the instead of you know formation of lead sulfate, there will be decomposition of lead sulfate on both sides. Let me just write those down as well. So this is how the equation will actually appear over here. Likewise, the overall cells reaction will also be changed. So as you can see, the cell reaction will also be changed, which means simply the opposite reaction, reverse reaction will occur, due to which the cell will be charged and there will be formation of lead as well as lead oxide on both electrodes. So this is how the reaction will occur, and cell will again be ready for the supplying energy. Moreover, there are some other MCQs point which I would like to highlight over here, that here this battery has several cell dividers, right? Cell dividers or glass sheets, as well as the battery has some these several sort of electrodes which are present over here are connected in series combination. That is why they are giving us a voltage of 12 or 6 volt. If it would be in parallel, then it won't give us such a huge voltage. And apart from that, um, this is a basic concept about it. In next video, we are hopefully going to discuss some new cells.